Imagine witnessing an explosion so powerful that it outshines every single star in the entire observable universe combined. Not for a million years, not for 1,000 years, but just for a few seconds. And here's the part that will genuinely disturb you. This happens in our universe almost every single day, and most people have absolutely no idea it exists. We need to talk about gamma-ray bursts. And once you understand what these things actually are, you will never look at the night sky the same way again. Let's start with something that breaks your brain immediately. The sun, our sun, produces enough energy every second to power human civilization for roughly 500,000 years. That sounds incomprehensible, right? Now hold on to that thought, because a single gamma-ray burst releases more energy in 10 seconds than our sun will release across its entire 10 billion year lifespan. Read that again. 10 seconds versus 10 billion years. That's not science fiction. That's peer-reviewed astrophysics published in journals that some of the greatest scientific minds on Earth have validated and cross-confirmed repeatedly. But here's where most science communicators get it wrong, and this is where it gets genuinely controversial. People talk about gamma-ray bursts like they're this distant, irrelevant phenomenon happening somewhere out there in the cosmos with no connection to us. That's dangerously incorrect thinking. These events are so luminous, so extraordinarily powerful, that astronomers have detected them from over 13 billion light-years away. Let that sink in for a moment. The universe itself is approximately 13.8 billion years old. So we are detecting explosions from light that left its source when the universe was barely a few 100 million years old. We are literally watching the ancient, violent childhood of the cosmos, and we can see it from here. Now, the science community has identified two distinct types of these bursts, and understanding the difference matters. Long gamma-ray bursts, which last more than 2 seconds, are associated with the catastrophic collapse and death of massive stars that are roughly 20 to 30 times more massive than our sun. When these stellar giants exhaust their nuclear fuel, their cores collapse in milliseconds, forming either a neutron star or a black hole. The resulting explosion doesn't just send debris outward. It launches two concentrated, focused beams of gamma radiation traveling at the speed of light with an energy density that is genuinely beyond human intuition. Short gamma-ray bursts, lasting less than 2 seconds, come from something different and equally dramatic. They occur when two neutron stars, or a neutron star and a black hole, locked in a billions of years-long gravitational dance, finally spiral into each other and merge. In 2017, astronomers confirmed this directly. The event GW170817 was simultaneously detected as both a gravitational wave and a short gamma-ray burst, marking one of the greatest observational achievements in modern astronomical history. For the first time, humanity watched two dead stars collide and confirmed that this collision produces not only gamma-ray bursts, but also forge heavy elements like gold and platinum through a process called kilonova nucleosynthesis. The gold in your jewelry almost certainly came from an event like this. That's not poetic. That's documented science. Now stop, because here's the pattern most people don't expect. We've been talking about how distant these bursts are, and your brain naturally categorizes distant as safe. Let's dismantle that assumption carefully and honestly. The brightest gamma-ray burst ever recorded by modern instruments was detected on October 9, 2022, and the scientific community gave it a name that says everything. They called it the boat. The brightest of all time. Designated GRB 221009A. This burst originated approximately 2.4 billion light-years away and was so energetic that it physically ionized Earth's upper atmosphere. It disrupted radio wave propagation on our planet. From 2.4 billion light-years away, it reached through space and touched our atmosphere. Instruments that weren't even designed to detect such events were temporarily blinded by it. The scientific papers published on this event in 2023 and 2024 confirmed it as a 1 in 10,000 year occurrence, meaning an event this powerful at this distance is extraordinarily rare. But it happened in our lifetime. And here is where the real conversation begins. Some astrophysicists have modeled what a gamma-ray burst from within our galaxy, aimed directly at Earth, would look like. The estimated safe distance is roughly 8,000 light-years. Within that range, a beam directly pointed at us would strip away the ozone layer almost entirely, exposing the planet's surface to lethal ultraviolet radiation. There is a compelling and growing body of scientific literature that links a major mass extinction event approximately 450 million years ago, the late Ordovician extinction, to a possible gamma-ray burst. This hasn't been proven with absolute certainty, but the hypothesis is taken seriously by serious scientists. The nearest candidate star capable of producing a gamma-ray burst in our galaxy is WR104, located roughly 8,000 light-years away. Whether its poles are aimed toward Earth remains a subject of active scientific debate. The current scientific consensus, however, is that the probability of a threatening event in any human-relevant timeframe is low. But the universe doesn't ask permission. Here's what this all comes down to. We exist on a pale blue dot suspended in a cosmos that is perpetually violent, perpetually transforming, and perpetually creating events so extreme that our language barely has words adequate to describe them. Gamma-ray bursts remind us that the universe operates on scales of power that dwarf everything we've ever built, imagined, or worshipped. And they remind us that knowledge, real, rigorous, honest scientific knowledge, is the only tool we have to understand our place within it. If this expanded the way you think about the universe, follow this page right now, because we go this deep every single time. Here's what I want to know from you. If astronomers detected a gamma-ray burst aimed directly at Earth with 24 hours warning, what do you think humanity's response would actually look like?